Mr. Ndo,
Da,
Mr. Ndo,
da.
can you request the fellow student to move to a quiet place because there is a word behind.
Oh yeah, exactly. Hello,
Nothing.
Charles.
I was a rasa to Tomana.
I got Thomas, you know, ne?
All right.
Yeah, let's start. So I was explaining that today we are going to cover what is called the cofactor. So cofactor is under chapter 2, of which in this chapter we have covered two important things. So the first one is the determinant of 2 by 2 and determinant of 3 by 3. So I would like to find out from you if you are familiar with these two before we go to cofactor, because cofactor relies to what we have done under these two topics. So the determinant of 2 by 2 and the determinant of 3 by 3. Are we all fine with regard to these two sections for finding the determinant of 2 by 2?
Mr. Ndo,
Yes.
the determinant is the one we did that we changed the row to be column.
No, that is the transpose.
Oh, that's a transpose.
Yes. So let me remind you of the determinant. Let's start with the determinant of 2 by 2. For example, let's say we have this matrix of 2 by 2. If we want to find the determinant of that, so it's going to be 1. It's going to be cross multiplication. This multiplied by that is going to be AD, and then this with that is going to be minus BC. So that is how we find the determinant of 2 by 2. You multiply the diagonals and then you subtract the non-diagonals.
Okay.
We have covered this. So it's how we calculate the determinant of 2 by 2. And then the determinant of 3 by 3, that's when we have to hold some components of the matrix. For example, if we have a matrix A, B, C, D, E, F, and then G, H, I. So what you do under this to calculate for the determinant, you hold the first component there. So if you hold the first component, it's going to hold all the components on the first row and the first column, and you will be left with E, F, H, I. And then on the second one, it must be minus. So it's minus B. It's going to hold the second row and the first row and then the second column. And then it's going to be D, F, and then G, I. And then the last one is it will be C, and then we have D, E, and then G, H. So that is how we're supposed to calculate the determinant of a matrix of 3 by 3. So you hold the first row in order for you to obtain the determinant of 3 by 3. Rockens.
Hey.
Yeah, you must remember this. Then the other important section, which I want to revise with you before we get into the cofactor, is for calculating the determinant by using row reduction. So row reduction. So this section I'm going to cover with you immediately after we finish with the cofactor. So, but from your pamphlet, I've seen something which I don't know if he excluded it purposefully or not. But there's another thing which is called manner. It's not just the cofactors we're supposed to calculate. We also have to calculate the manner. But at later stage, if I realize that you also have to do the manner, I'm going to include that for you. But for now, let's just cover only those things which are in the pamphlet, of which is the cofactors. We are fine on that one. Eh? So now let's quickly go to the cofactor. So the question is, how are you supposed to calculate the cofactor? Actually, you cannot calculate the cofactors without getting the manner. So this is how you're supposed to calculate the cofactors. So cofactors, they are calculated by using this important formula of C, which stands for the matrix IJ. So this simply means that this matrix is having rows which are indicated by I and columns which are indicated by J. So, and this must be equal to -1 to the power of I plus J, and then multiply by the manner. So this is the manner that I was referring to. So which is very, very important in this case. So it's the manner IJ. So that is the formula we're going to use in order to calculate what is called the cofactors. So whenever anyone tells you about what is called the cofactors, this is the formula that must come into your mind. So in order to calculate the cofactors, which are indicated by this capital letter C, you must use the formula of -1 to the power I plus 1, and then multiply by the M, where M stands for the manner, IJ. So the I stands for the rows and the J stands for the columns. Are we all together with regard to that?
Yeah, we are all together.
Okay, then now the starting point is for us to get this M, the manner of the matrix. So how do we calculate the manner? We have done this already, but you will see how we're going to calculate the manner of the question. Let me take questions from the pamphlets you sent me. So let me take just one question from there.
Bondo.
Da.
Hi, network kundi. Or na ba bangwe ba go dinwa network or like none not but
Zemari nazino tiko para.
zwino ndi khou vha fa ndi tsheo nna
Oh, okay. So zemari a chinda explain chine chofara.
a thongo pfa tshithu.
Okay, I know it's okay. I'm going to summarize. So I'm not taking seeking for example that you can do, but I will explain to you again so that you see all these things that we're going to do just now. So I'm looking for a 3x3 matrix that we can do in order to attempt these questions for manner and cofactor. Okay, let's use this question. So A is equal to 1, -2, -3, 1, 0, 4, and then 7, -1, 0. Okay. Let me just summarize what I mentioned before. So I said to calculate the cofactor, you use this formula that you have here. I believe you are here now. So we use this formula of -1 to the power of I plus J, and then multiply by IM, where I and J, I indicates the rows and J indicates the columns. And the M is the manner of which I'm going to calculate with you just now. The capital letter C are the what? Are the cofactors, of which is the main thing for the lesson today. So at the end of the day, we must be able to calculate the cofactors.
All right. Yeah.
Okay, Jean-Marie, the very first thing we're supposed to do is calculate the manner. So if we have a 3x3 matrix, the total manner that we're going to have, there are 9 in total. Is 3 multiplied by 3, which are 9 in total. These are long calculations we're going to do here, but they are very, very simple. You're going to get this right without any hesitation. is the same with the C, the cofactors. So I want to get many cofactors. So, but it depends on which cofactors you're looking for and on which manners you're looking for. So like in this case, if we're looking for the manners when we are holding the first row, so it means you just have to do 3 of them. Instead of having 9, you then just have to do 3 of them. You don't need all the 9 because you could be like repeating what you have. Okay, let's start with the first manner. This is how we calculate the first manner. The first one, let's say we are calculating for row 1 and column 1. So how do we calculate the manner for row 1 and column 1? You do exactly the same thing that I've explained to you when we get the determinant. So you're going to hold the first column and the first row. Which components do we left with when you hold the first row and the first column?
On the row, it's 1 and 7.
Yeah, which if you hold all components on the first column and all components on the first row, which components will be left with?
1, 7, -2, -3.
These ones you hold them. You don't consider them, these ones, because we hold the 1. So this you don't consider.
0, 4, minus 1, 0.
0, 0, 4 minus 1, yeah.
Yes, this is the manner for M11. First row, first column. That's how you complete the manner for first row, first column, of which when you're here, I believe you know what to do. This is just the determinant of 2 by 2. So it's the determinant of 2 by 2, which you obtain by multiplying this with that is going to be 0, this with that is going to be negative into 4, which will give you 4. So it means the manner for.
So we must carry on. So we must carry on with the calculation.
Yes, yes. So now, after getting the manner, you can then go to obtain the what? The cofactors. Ne? So cofactors for first row, first column. So it's going to be equal to -1. The I and the J are 1 there. It's 1 plus 1 and then multiply by M11. So it's -1 to the power 2, which is 1, multiplied by M11 we obtained from the previous question, which is 4. Therefore, the cofactors for row 1, column 1, is what? It's equal to 4. Did you see how?
Oh, by using the
That's how you calculate the cofactors.
You said, how did you get the 1 plus 1 there? The exponent there.
This one.
1 plus 1. It's -1 to the power 1. Yeah.
Yeah, it's -1
exponent.
to the power 1 plus 1.
How did you get the 1 and 1?
It's
row 1. It's row 1 plus. Okay, it's row 1 plus column 1. Okay, thank you.
This is the formula that we have.
Okay, thank you.
Can we go to the second manner? For the second one, we're going to have M12. Rotating. Can you tell me the component for M12?
It's row 1, eh? Row 1, column 2. So we're gonna cancel this. It's -2, -1, -3, negative and 0.
No.
Huh?
Is it we're holding this and that? What do you like when you hold this with?
1470.
Yes, exactly. It's 1470. That is how you get the manner of this, of which this is just the determinant of 2 by 2. This multiplied by that is going to be 0, minus this with that is going to be 4, multiplied by 7, of which will give you the answer of what? What is the answer for this?
28, -28.
Yes, so that is the manner for row 1, column 2. And after obtaining the manner, you can then obtain the cofactor, which is going to be -1 to the power of 1 plus 2 multiplied by M12. That will be -1 to the power 3 multiplied by -28. So the answer of this is going to be 28. Are we all together with regard to this?
Yeah.
Can you do?
Yeah, all together, Mr. Ndo.
Can you do for M13 and C13? Tell me the answer you obtain for M13 and C13.
-170
Yeah, write the answers for M13 and then the answer for C13.
-1
Okay.
that's 3. Then 3
No,
and -3.
no, it can't be.
It can be.
It can't be 3.
Wait. One. 3. Huh?
No,
Yeah.
it can't be. Okay.
Isn't it 1?
Uh,
1.
yes.
1 plus 3. Then it's -1 to the power 4 times 1
Yes.
times 3. I'm getting 3. I don't know.
So let me find out from him. What are you getting? I want to compare the answers.
The first one, the minor, is
Ndo.
-1.
Yes. Which answer are you getting? I want to compare the answers with his.
I'm getting 3. The cofactor, I'm getting 3.
He's getting cofactor of 3, and which answer are you getting for cofactor? Yes, you are getting answer of 3, right?
Yeah.
Yes, I now want to find out from him which answer is he getting for cofactors, so that we compare the answer you get and the answer is getting. Hello?
Mr. Ndo.
Nda, wako wana pindulivyo kamenya, cofactor.
Zvauti atikunwara chitu ndikototecheresa ndokufundiwa fedzi mara ansara ndiko zamuivona kuti hazvikondiri zviwani taizotina bhuku na calculator.
Okay, I know it's okay. Let me quickly do it so that you see how we get the answer. This is how it's
Yes.
So it's going to be -1, then
Yeah.
we have 1 I, we substitute 1, we have j, in this case is going to be 3, and then m
Yes.
and 3. So we are going to have
Yes.
negative 1 to the power of 4, and then the
Yes.
minus in this case is negative 1. So negative 1 to the power of 4 is 1, multiplied by negative 1. Therefore,
Oh,
you see that? That's how you get this question.
okay. Yes, I saw my mistake.
Yes, yes. So now we supposed to do this
Okay.
for nine of them. That's when we will obtain what is called a core factor, because core factor is going to be given in this form. We're going to have C11, C12, C13, C21, C22, C23, and then the last one is C31, C32, and then C33. So what did we get now? We now have C11, which is equal to what? What is C11? Is 4, right?
Yeah.
C12 is 28.
28.
And C13 is negative 1. We are now left with C12, C22, C23, C31, C32, and then C33. We have to do all those calculations. We can't get the core factor without having this. So we are now left with these other ones. Let's quickly do them so that you see how we get the final answer. Or is it something that you can be able to get?
Now we can be able to get, Mr. Ndo. I think let's proceed. We can be able to find those things.
Definitely. It's a very, very interesting and simple topic. Okay, let me go quickly. Yes.
What I want to know, how do they ask the question? They ask us to find the core factor.
Yes, the question will be specific to find, they will require you to find the core factor or the manner. It's either the core factor, the first question may be to say that you need to find all the manner. And then the second question.
Mr. Ndo.
Yes.
Mr. Ndo.
Yes.
Did you check our question papers, or must I send them to you, or
you can
do you
send
have
the
them?
question papers? You can send the question papers so that we do those questions. I was just checking on the notes you gave me. But if you gave me the specific question paper, it's going to simplify everything that you're going to do. So on my side, I'm just giving you how they ask question with regard to the previous exam I've seen in several institutions. But if you have specific questions, you can send to me so that I refer to the question papers from your institution.
All right.
Yes, exactly. It's going to simplify a lot of things. So send
on this one, we must get distinction. Yeah.
Yeah. Okay, then now, can we quickly go to the second section I prepared for us to cover today?
Yeah, I think so.
All right. So it's similar to what we have done previously, but let me pick a question from this note. This matrix. So this is called is section number 4. Is calculate determinant. We are now calculating the determinant by row reduction. We are calculating the determinant by row reduction. So this is how we are going to do it. Let's say we want to calculate the determinant of this matrix. 1, 4, 5, 2, 3, 1. I believe you know the method I showed you already for calculating the determinant of this matrix, right? You remember the method that I used to calculate the determinant of this. So, but now,
3 by 3.
Yes, we are now focusing on this method. Is there, if you check the content of your module, you're gonna see that there's a section which requires you to calculate the determinant by using the row reduction. So the question is, how do you calculate the determinant by using the row reduction? So I'm going to answer that question by using this as an example. So you can calculate the determinant by using the row reduction in this way. You are required to obtain the zero in all components below the diagonal. Are we all together? You are
Yes.
required to find the zeros in all components below the diagonal. Once you obtain the zeros below the diagonal, you then have to multiply all the components on the diagonal, and that is going to give you the determinant. Are we clear on that?
Let's do it practically so that we can be clear so far.
Okay, it's -2, 1, 3, 1, 4, 5, 2, 3, 1. So let's find the zeros here, here, and there. We can start with this zero. You remember the order of obtaining the zeros?
Yeah.
Yes, we are going to follow that order. Don't change the order in any case. This is the only order that can lead you to the correct answer. We first get the zero here. Can anyone of you tell me how can we obtain the zero here on where we have 1?
We are going to say
Where we have 1.
R1
A.
plus 2R2. Two R2 is gonna give us a new R2.
Yes, very true. And then you are allowed to do the same with the, is it this equation we established here is for dealing with the row 2, right?
Yeah.
You are
I
allowed
can't see.
this equation we have established here is for dealing with the row 2. You are allowed to establish the equation that deals with the row 3 at the same time, without even getting into to the next step. Can we establish the equation that deals with what's the problem now? You can log out and log in again.
I'm sure the camera or what mara tikobona zvavhuti dzinambora
Dzikobonera zvino.
as queen.
So I was explaining that
For the last row, we are going to have -2.
yeah,
Near. We are going to have R1 plus R3.
R3, which gives us R3, as simple as this. So let's quickly do that and see what we get. So the first one is not changing, and then the second one, for sure, we want a 0 there. It must be a 0, and then here is going to be 1 plus 8, which is 9, and then here is 3 plus 10, which is 13. And then here we add this with that, is going to be 0. This with that is going to be 4. This with that is going to be 5. Rotten discussion.
Yeah, Mr. Nzo.
Yes.
We can't have 5 at the last one. We must have 4.
Oh, yes, you are very, very right. It's not 5, it's 4. And now we are only left with this here. How can we obtain the 4? The 0 there?
Hey, this one is gonna be a little bit difficult, eh?
Yeah, for sure.
Because we have to deal with 9.
Yeah, and therefore, yes, exactly.
So we have to make sure that we came with the equation that will combine 9 and 4 so that we get 0. So we have to use the calculation here.
Yeah, very true. Okay, so but I can make it simpler for you and say you can divide row 2 by 9 to obtain row 2. That makes sense, right?
Yeah.
Yes, Then you will then have a new equation which is negative 2, 1, 3, 0, 1, 13 over 9, 0, 4, and then 4. So to obtain, and it's a must that you must use this.
Mr. Endo,
Yes.
so we are also allowed to divide, né?
Yeah, you can divide in this case. It's okay. So then from there, you then have negative 4 root 2 plus root 3 in order for us to find root 3. So we'll have negative 2, 1, 3, and then 0, 1, 13 over 9. And then on the last one, what are we going to have? We're going to have a 0, and then here 0, and then here. Is there anyone who's having a calculator there? What is negative 4 multiplied by 13 over 9 plus 4? Negative 4
Negative 4.
multiplied by 13 over 9. And then plus 4.
Negative 16 over 9.
Negative 16 over 9. Then now the determinant of A is going to be negative 2 multiplied by 1 multiplied by negative 16 over 9. What will be the answer of that?
Mm. $32 over 9.
Yes, so that is the answer for the determinant of A. So determinant of A.
Oh, this is when we are using the reduction, the row reduction.
The row reduction, yes. It's when we're using the row reduction.
Okay.
So
These things, I think
we can
they are not
only-
simple. I mean, they are not difficult. They just need us to work hard on them. Eh?
yeah, and don't underestimate this, because one mistake, you are gone. So you need to revise this at all times so that you make sure you don't forget one step. Otherwise, by nature, these things, they are simple.
You know, one msibachi kwamba ngororo na msinga masiyari nandi kutoda inverse ya 3/3 ndombodi ndikotevedza formula nda kako calculator 1 instead ndive 1 ndamudive 9 ndaronga zvotso yaphanza zvotse ndichichekurisa mistake ndaona uri ndihela 1 ndakaka inge instead of 1 ndove imwe nomboro nga nda 1.
Yeah, exactly. One mistake, you might not be able to get to the correct answer. So, but by nature, this course is not difficult.
Yeah.
Otherwise, that is what I prepared for today. Unless if you have any other question.
Atina question bondo ndakotombera nyana stuku nendo bafonera masiyara musi ndiko shuma ila topic ya chapter 1 ile feze yakori triangular yar mini ngori thamsi batotauchedza feze uri triangular biberi vari kuita mini ifala khaile ngori vari kuita mini zvazoshavanya na stuku.
Okay. Let me explain that to you just now. So that topic is about. Yeah, exactly. So it's about diagonal, triangular, and symmetric matrices.
Yes.
So diagonal, we are just referring to the components which are here. So negative 2, 4, and 1. Those are the diagonals. So maybe the question might say, select the components on the diagonal. So it means you're going to select negative 2, 4, and what? And 1.
Okay.
Components on the diagonal. It's negative 2, 4, and 1. All right, and then the second, it's about a triangular. So triangular, we are referring to a situation where in below the diagonal or above, it doesn't matter, either below or above, we must have zeros. So whenever you see a situation wherein we have zeros, then you can say that we have a matrix which is triangular. For example, this matrix that we have here is a triangular matrix. Why? Because below the diagonal, we have the what? The zeros.
Oh, ngayimwendela bondo ziyakhoneza uri show that these matrices can be a triangular matrices or can be written as a triangular matrices.
Yeah, you can have a question like that. Maybe let me elaborate what they can say. They might ask you, transform this matrix to be in